Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
That actually could be an edge for you and your company with your competitor or against your competitor, because your customer might be very happy that you're able to deal with some of this model-based definition data. So
hello and welcome to the Being an Engineer podcast. We're speaking today with Daniel Campbell, who is VP of Model-Based Definition at Capvidia. Daniel has more than 20 years of experience in the field of digital metrology, software design, and model-based definition. He's also currently the chair of the ANSI Working Group and a member of the board of directors of the Dimensional Metrology Standards Consortium. Daniel, welcome to the show.
thanks, Aaron. Thanks for having me here.
All right. So you are an expert when it comes to MBD. Let's start there. Really basic. What is MBD? What does the acronym stand for? And what is it actually?
Yeah. No, it's a good question. It's one of the alphabet soup kind of topics that's out there. So MBD, it stands for model-based definition. And the model that we're talking about here is a CAD model, a 3D CAD model. And the idea is that when you're planning a product, you plan the 3D shape, and then you add all kinds of annotations, all your GD&T and all your tolerances and everything like that. All of that goes into your product design and your manufacturing plan. And the way that this is typically done now is people will use a 3D modeler like SolidWorks or Creo or NX or CATIA to define the shape. But usually a 2D drawing is created for all of these tolerances and GD&T and all the manufacturing metadata. The idea with MBD is to stop generating a 2D human-readable document and put it all on the model so that you have one single source of truth, which has your shape definition and has all your manufacturing metadata as well. And so, the idea of what this enables, it allows, just like how you could take that SolidWorks model, maybe save it to step and load it into a tool like Mastercam for machining. Now you can take a SolidWorks model with 3D annotations, an MBD model, and you can export that with annotations into, for example, a CMM software package. And you don't need to be typing in, you don't need to take a 2D drawing that was printed from SolidWorks and then move it over to Quality and start typing that back into the CMM software. Obviously, it's pretty silly. So it's a big revolution that's happening right now, really, in manufacturing.
And it just makes so much sense, right? You've already created the geometry. That there are a few things in drawings that you can't pull directly from the model, like material and surface finish and some tolerances, right? Things like that. But by and large, you've already defined everything. So like you said, it feels so wasteful to go back and spend hours creating a 2D drawing for a shape that you've already defined all the geometry.
Yeah, no, it's funny actually, because everyone's so used to doing it, but when we first start talking with our users about MBD, we'll usually kind of pull everyone out of the situation and think okay, what are you doing? You're defining this shape, you're creating a drawing, you're printing that to PDF, you're taking the PDF over into manufacturing and quality, you're having them read the PDF and then type that data back into a different system. Why are we doing this? This is insane, so it's good.
Yeah. I wonder why that didn't happen just when CAD became a thing, right? Maybe people were so steeped in the tradition of creating drawings, no one even thought about it. Or maybe the technology wasn't there to do it. I don't know. Do you know anything about that? The history
it is an interesting question, actually, because a lot of the technology for applying 3D annotations has been in the CAD system since the year 2000. But it was never largely adopted. And I think a lot of people have theories about this. My theory is that there was never a focus on machine-readable annotations. The focus was always that the annotations, they were readable to a human, but they weren't written in some type of standard format such that downstream software can read it and automatically operate from it. And that's really the ultimate benefit of MBD. And that wasn't quite there at the beginning, and so I think it hurt the uptake.
So let me just make sure I understand this completely. You're saying that with MBD, model-based definition, I can send out my 3D model without having to spend any time creating a 2D drawing. Effectively, the 2D drawing is eliminated, doesn't even exist anymore. Is that right?
That's often the case. It depends on the situation. So we do have customers that do not generate a drawing. They have all of their products are 3D model-based definition, and they have no drawings that they generate. We also have a lot of customers that they use the 3D MBD as their primary product definition with the 3D annotations, but they also create a drawing, which is basically a derivative of the 3D model and annotations. And that's just because there are a lot of people, often it's a lot of the suppliers to some of our customers that basically insist on drawings. I mean, they don't want to deal with anything in 3D. They just kind of want to deal with things the way it always was. And so, yeah, that's fine. But as long as it's kind of a derivative piece of data, that it's not the primary piece of data.
Yeah. Yeah. For a long time and still today, that's still the current state of affairs. The drawing is your contract really with your manufacturer. And so you and other groups are trying to evolve that paradigm into one where the contract is now the MBD model, not the 2D drawing, right?
Yeah, that's exactly right. I mean, at some point, there has to be sort of an official, this really is, if we go back to, if we get into a legal battle, this is the definition of the product. And you're right, it typically is the actual PDF drawing. So, with a lot of our customers, it's always kind of an interesting, big business shift, actually, like to make that and for them to start consider the model as the primary. There is some precedent for this starting to happen, though, which is especially in aerospace and defense. So a lot of contracts that come from the U.S. Department of Defense, but also some other defense ministries from other countries, they're putting out new contracts, and part of the contractual requirement for this is that the product definition has to be a 3D model-based definition.
Oh, interesting.
It should not be a drawing. It should be a 3D MBD.
Yeah.
And so that's really like changing the market rapidly, because obviously these are very big contracts with very big companies like Lockheed and Raytheon and so forth. And so, if they want to play ball, they have to learn how to treat the model as the product definition.
That's great. I've heard, this might be apocryphal, I don't know. I've heard that Tesla is fully MBD. They don't do drawings anymore.
Yeah, that's right. MBD. I mean, they started from like a sort of a blank slate, and so I think that was a really smart and obviously very forward-looking company as well. So I think it was very smart of them to just say, no, we're going into the future here. We're going to use the latest technology.
Yeah. So what are the biggest obstacles for a company to incorporate MBD into their workflow?
Yeah, I think the biggest thing is simply that it's a very big transition. I mean, if you think about how manufacturing works so well, how it is that you're able to have, carry an iPhone in your pocket, which is this, wonder of technology that you're able to buy for, under $1,000 and put it in your pocket and buy a new one every few years. The only reason that's able to happen is because of how efficient manufacturing is. There's no way that otherwise that would be able to happen. And what that means is a very repeatable process. The business process is extremely refined. You don't change things unless they're absolutely broken. And so now you have this idea of MBD. Hey, let's throw out the drawing, and instead we're going to change our entire workflow so we're working from a model-based definition. So that's the thing that's tough. I mean, it's requesting a big change just in how business is done. But the funny thing is it's kind of a tricky area because, every major company you talk to, they understand that MBD is absolutely inevitable. It's coming. They're going to have to figure out how to use it effectively and how to implement it in their workflows. Otherwise, they'll lose their competitive edge because they know their competitors will do it. But on the other hand, they don't want to, they don't want to break what isn't broken.
Yeah.
And so that's kind of, where we are right now. So it's an interesting period. Yeah.
It seems very similar to the whole EV revolution, right? Like all the manufacturers, the auto manufacturers knew that EVs were coming, but no one really wanted to jump in. And then here's Tesla, going back to Tesla. I'm not a Tesla fanboy, by the way. They're cool cars, but whatever. Anyway, Tesla jumps in and like they have this wild success. And now everyone is jumping on that EV bandwagon. So I guess it just takes a few big companies to get the ball rolling, to get that started. And then hopefully everyone else jumps in.
Yeah, that's true. Actually, it is a very good parallel because I mean, when people, when an outsider, you see a Tesla versus an old muscle car or something, you think, yeah, I mean, it's got four wheels, it's a car, it's the same thing. It's an entirely separate device. It's a totally different type of product.
Yeah.
And for Ford to retool and start making EVs instead of traditional drivetrain cars, I mean, it's a huge change.
Yeah.
But they got to figure it out.
Let's talk about some of the practical applications. I mean, manufacturing, we've already kind of talked about that a little bit, but MBD goes beyond just manufacturing. How else is it used in the industry?
Yeah. So I think that the biggest practical applications is really on the quality side. I mean, that's especially where a lot of this stuff is applicable. And the reason is I mean, if you think, what do I see on a drawing? You pull up a drawing, what do you see? It's mostly quality criteria, GD&T and dimensions and tolerances and things like this. Like you were saying, surface finishes. I mean, that's at the end of the day, that's a quality criteria. This is how bad it's allowed to be. And you need to measure it and make sure that its badness is within that range. And so that's like where, that's where a lot of this data is consumed. And so a lot of the usage of model-based definition is in the generation of the quality plan, in the sense of coming up with a quality plan that will sufficiently sample all of your batches of parts and things like that, and do some statistical analysis on it to make sure that you have a process that's under control and generating good parts and stuff like that, but while at the same time making it as cheap and as simple a quality process as possible. So there's a lot of planning, like high-level quality planning like that, but then it also goes down even to like the CMM, the coordinate measuring machine domain, or 3D scanning, which is a big thing now, where you're doing, dimensional metrology, gathering point clouds, and then evaluating point clouds against the tolerances that are listed there on the 3D MBD model. So that's kind of the biggest, that's definitely the biggest sort of practical application for MBD right now.
Okay. Here at Pipeline, we do a lessons learned review each week. We have a weekly team meeting, and one of the little presentations each week is a lessons learned review. And so one of the engineers on the team is assigned to go out and find some lesson that was learned that can be shared with the rest of the team. And this week, one of our project leads was in charge of making that presentation, and he shared an experience he had maybe a year or two ago where he ordered some parts for a project, machined parts, and they came in, and he took a quick look at them, cursory glance. Yep, looks like everything's good. Put them on the shelf, and a couple weeks later, when all the other parts got in, went to start building this assembly. Well, now he starts actually putting it together and realizes, oh, shoot, the countersinks are all missing from the other side of this plate, and I can't use it. And at that point, it was a couple weeks later. We didn't have time to send it back to the machine shop, so we ended up just getting a countersink bit and doing it ourselves, which is kind of messy, and it requires time that we should be spent doing other things, right? So his lesson learned was make sure you really inspect these parts before just putting them on the shelf and waiting, which in theory is wonderful, right? But if you start thinking about the overhead required to do that, especially if you're doing that on all your parts, so you have 50 or 100 parts in this assembly, and for a person to inspect all these parts, arguably right. That's not a good use of time, especially you're looking at this thing with human eyes, and how do I know if a hole is off by 30 thousandths of an inch, right? I won't know. So I might look at it and think, yeah, it looks fine, but it's not until I start putting it together that I really know there's a problem. So all this is leading up to an actual question I have. Is there a future? And I think maybe to some degree that future is already here. But as I was thinking about this, I was thinking to myself that it would be so cool, so great if we just had this little scanner, right? And all we do is put a part in the scanner, push a button, it scans everything and automatically pairs it with its digital twin, which we'll talk a little bit more about later on. But it pairs it with its digital twin, which has all the MBD information and says, yep, this part is good, or nope, this part is bad, and here's why. Does that technology already exist? Actually,
it's quite close to being something there. There are a couple very small nuances to what you're saying. I mean, especially something like maybe how that part is going to be fixtured within the envelope of this measuring device or whatever. But aside from little nuances like that, yes, that does exist, and a lot of companies are starting to use it. I mean, it's one of these things that it's a lot of newer engineers that are starting to get into this, but you have devices that could capture very dense sampling patterns, very dense point clouds on parts. Maybe they'll spin the part around and kind of capture it from a 360 degrees. And with that information, you can do your analysis and compare it to the GD&T that's already embedded in the part, and you can get a very quick, up or down as far as whether all those things are within tolerance. And actually, there's even more information that you get. If you imagine, maybe that's a casting that you have, and you might have a profile tolerance on some, curved surface or something like that. After you get that scan, you could look at it and you could see a color map that will tell you, yeah, it is out. Okay, where is it out? Well, there's a pocket over here where it really seems to be out. And so, okay, we need to go back to that mold and fix the mold at this specific location, So there are even other benefits aside from that. But yeah, automated inspection, I mean, that's a big thing that people want to get to. Because, I mean, again, if you think about, what's happening, you have the engineer on the one side thinking about the design intent of the part. So they'll put some tolerances on it. And then, it goes to a PDF. And then the quality engineer types that in and, whatever. I mean, that design intent is programmed into the part at that point when the designer's applying it. Now we're getting to the point where there's this downstream software should just be able to directly read what that design intent that the engineer put on and do the validation accordingly. So,
yeah.
So it's a complicated journey, but yes, it is definitely headed in that way. Yeah.
That's amazing. I can't wait till we get there. I mean, it doesn't make sense to pay an engineer to spend hours and hours inspecting parts like that. But if you could pair an intern with technology and it takes, half an hour or something, that's a no-brainer.
Absolutely.
All right. Well, one of the big benefits that seems very clear to me of MBD is just the time that you save not creating 2D drawings. Are there other, maybe more nuanced benefits to MBD?
Yeah. Actually, a big one, and this is one that a lot of very large companies, large manufacturers are pursuing. That's mostly who we deal with. Is the idea of adding repeatability or uniformity to their business process, to their manufacturing process. And so what I mean by that is just that, again, you have this drawing, it's a PDF, and you have, 20 different quality engineers who might be tasked with that specific measurement. Let's say we're talking about a measurement. Depending on who it is, they might have different skill levels. They might have different interpretations of GD&T. Some of them might be mistaken about one thing or another. One person maybe didn't get such great sleep last night, et cetera. And so the outcome, if you hand that same drawing to 20 different people, you might get totally 20 different results back as far as the product that actually gets created. When you have a software-based process, I mean, it's a deterministic workflow. You put in an input and you get the same exact output every time. And so whether we're talking about, high-level quality planning or, welding, which is another area that is in, is in scope for MBD, CMM programming, stuff like that. You insert a digital data set, it's interpreted by software the exact same way every time, and you get the same exact output. So repeatability. I mean, again, we talked earlier about repeatability being a big thing for manufacturing. And so I think that's probably one of the big benefits of model-based definition.
Wonderful. All right. Well, I'm going to take a very short break here, share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. We're speaking with Daniel Campbell today, VP of MBD at Capvidia. Daniel, what's the workflow like for MBD? So let's say I've created my 3D model, SolidWorks or Creo or whatever. Now what? What happens next?
Yeah. So the biggest sort of fork in the road versus a drawing is that normally you generate the shape in your CAD tool, and then you generate your drawing. You'd add some projection views to the drawing, and then add your annotations to that drawing. So instead of doing that, now what's going to happen is you're going to add those annotations directly to the 3D model. You don't need a drawing anymore. Those get added directly to the 3D model, and each of the annotations that are there will reference the surfaces that they're meant to control. So you add those surface references. And then from there, you could take that digital data and pass it down to, whatever downstream tools might exist in manufacturing, in welding, in quality, in assembly. And then, in general, the two major use cases would be a human consuming that data. So, which is, similar to a drawing, except it's a little bit more user-friendly in the sense you could rotate it, you could see the 3D shape, you could see exactly how the annotations control each different surfaces. So the human consumption of that data is sort of one general area, but the big game changer is the machine consumption. That data is consumed directly into a software tool to do some automated process.
And where are those annotations added? Is that like, if I'm using SolidWorks, is it in SolidWorks, or is that a different program that does that?
It would be in your CAD tool. And depending on which CAD tool you use, sometimes you will need either a higher level of the CAD tool, or maybe a certain module to the CAD tool. That's something that, everyone should contact their CAD reseller about that and ask about how to enable model-based definition or 3D annotations to start looking into that. But you do the authoring right there in the MBD. And so that way, actually, when you're using product lifecycle management, that model with the 3D annotations gets checked into your PLM system or your PDM system, and it's all controlled there with the model.
Got it. Okay. And I think they're plugins, right? At least Capvidia makes some plugins for like SolidWorks. And how do those work?
Yeah. So typically once you're, when you're going from one CAD system to the next, or from one CAD system to something downstream, like right now, if you think about a CAM workflow, you want to take a SolidWorks or a CATIA model and put it into MasterCam or something like that. Usually what you'll do is you'll export a step model or maybe an IGES model, and then you take that model to the downstream software. The reason is you use neutral standard CAD formats to transmit this CAD data from one software tool to another. It's the idea of interoperability between proprietary CAD systems. It's the same idea for model-based definition. There are some neutral ISO standard CAD formats. So we use a lot of QIF, which is a relatively new standard. It's 7 or 8 years old. And then STEP AP242, which is an MBD version of STEP. We'll use those. Those get exported from your proprietary Creo or CATIA or SolidWorks file. And then you have that neutral standard so that any software downstream can read that tool. And so that's a large part of what our plugins do, is we'll publish that data from the native CAD system into neutral standard formats. And then our software platform, MBD Vidia, will be able to read these neutral files and do some quality planning, do ballooning, and things like this.
Got it. Okay, so some of these CAD systems, SolidWorks, Creo, CATIA, whatever, might not have these software agnostic neutral file formats available as an export option. And if not, that's where one of these plugins comes in.
Yeah, that's right. Yeah.
Okay.
Yep. Yeah, we're kind of experts, especially in the area of neutral data standards and CAD data interoperability and things like that.
Got it. Okay, cool. There's some terms that one encounters when reading about MBD, including digital thread, digital twin, and Industry 4.0. Can you talk a little bit about each of those terms? What do they mean?
Yeah. So they do get thrown around a lot, and actually, I think to the point that I know a lot of engineers that will sort of roll their eyes when they see somebody talking about digital thread or something. But that's just, I think, because the terms are abused, but they do encapsulate a valid concept. So the idea of digital thread is just that you want to maintain some type of digital traceability from your product definition, which is your CAD model, all the way down through manufacturing, through quality, et cetera. And so imagine this workflow. You have your CAD model. Let's say it's a Creo model with 3D annotations on it. That's your product definition. There's your digital product definition. You'll generate a QIF file from that, go into a CMM workflow, measure 20 parts. Now you have 20 digital representations of as-built parts. Maybe they're serialized parts. And so now you have between your product definition, like the ideal definition of what your product is, and then you have an as-built characterization of that model because of the detailed measurement you've taken. So now you've extended that digital thread from the design all the way to the as-built state. And actually from there, it gets into this next term, this digital twin idea, which is just, I have my real part here, serial number 123, I'm holding it in my hand, and then I have a complete digital representation of this in the form of my CAD model and my as-built measured data. So that's the digital twin concept, which is a powerful concept, obviously, in terms of the analytics you could do on a digital representation of your part. And then Industry 4.0, it encompasses some of these ideas, and it also encompasses a lot of other sort of future thinking ideas like augmented reality and big data analytics and things like that, and just using all of these ideas within the context of manufacturing. And so, having a digital thread, this digital thread of dealing digitally with your product definition and your as-built state helps to enable all of these Industry 4.0 ideas.
Got it. Okay, so digital twin and Industry 4.0, those were terms I'd at least heard before, was somewhat familiar with. Digital thread was a new one for me. Sounds like that's largely just traceability.
Yeah, I think that's right. I mean, that's basically what it is traceability, throughout your entire manufacturing process.
Got it. Okay, cool. At what point does it make sense for an engineering team to consider adopting MBD? Are there specific triggers that we should look out for as an engineering team, or different factors or clues that should tell us that it's time to start exploring making this change?
Yeah. I think usually what we'll recommend to people is that they'll jump into getting into like pilots, especially with NPIs, like with new product introductions. That's usually a good place. Like you don't want to necessarily take an existing product that's already defined on a drawing. You got a new product. Okay, draw a line right here and say, we're going to make this a 3D MBD and do some pilots with it and test the downstream consumption case. Generate that 3D MBD data set and work with downstream manufacturing and quality and talk about what are the consumption use cases and how can we derive value from this, because there is some pain, obviously, in switching the way you're doing it. So make sure that you get some value out of it as well. And once you start to kind of establish that value, people catch on to it and they realize like, it is a change, but there are all these benefits, and people start to figure out a little bit about the new tools. There's a little bit of a learning curve. But I think it's really, like these pilots, I think that are the sort of the fire that usually, the spark that will start the wildfire usually. And it's through those pilots you could usually figure out if you're a good fit for a model-based definition or not.
Okay. Now, most companies I know aren't using model-based definition yet, so it's not ubiquitous yet in the industry. What does adoption look like right now? I mean, are you seeing it accelerating, or is it still at like kind of a steady, slow pace? What should we expect in the next 5 years?
Yeah, it's picking up very, very rapidly right now. And it's being picked up especially at like the top tier OEM manufacturers, like the very, very large companies, and they are slowly starting to drive it down their supply chain. Like usually and that's really the large majority of our customers are like, Fortune 100 manufacturers. Wow. And because that's where they're especially interested in taking on this technology. They'll do some internal implementations usually first, and then they get into pushing it down their supply chain. And so right now, I think it's already starting to be, more and more common every day that you have manufacturers of all different sizes, maybe starting to see some data from some of their customers, and they're wondering like, "Oh, what am I supposed to do about this?" But people the large companies are jumping on it very, very fast, and I would expect that in the next 5 years, it'll start to become a lot more common.
Cool.
Which, by the way, is not to say that drawings are going away. I don't think they are. I mean, you have certain platforms like the B-52, which was developed in the 1950s, and that's still here. And it's going to be, the same story. I mean, they're going to be drawing-based products that are going to be around for another 100 years, at least.
Yeah.
And so that's something it's here to stay to a certain extent. But, we'll start to see much more of a shift towards the majority of products being MBD.
Yeah, that makes sense. Let's see, maybe just one more question and then we'll wrap it up here. What the adoption of MBD, making those changes internally is I guess one of the biggest obstacles in actually starting to use it. What are some of those operational or infrastructure changes that need to happen in order for a team to implement MBD?
Yeah, I think one of the things is that a lot of the technology is still early, let's say. So that's a lot of the technology on the authoring side, but also on the consumption side. Since, like, as you can imagine, since there aren't a lot of companies using MBD now, a lot of the software consumption of MBD data is not perfect. There might be a lot of things that are not supported and things like that. And so that, it's a journey for a lot of these downstream software implementers. And so that obviously is sort of, slowing things down a little bit, or it makes it challenging for people that are implementing. The other challenge is just learning new tools. I mean, it's a different way of doing things than the way things were done. And so if you have someone who's been, who's an artisan machinist, and that person has been working with drawings for 40 years, they're going to be more comfortable working with drawings, and they're probably not going to be terribly interested in moving away from drawings and adopting a different approach. And so actually it's interesting, but a lot of sort of, turnover in the workforce to younger, university graduates or whatever that grew up using SolidWorks. That's actually one thing where, we're starting to see MBD really be taken up in a much easier way, because they're just kind of more comfortable with software tools in general and so forth.
Right.
So
cool. Okay. Yeah. Well, anything else that we haven't covered that you think would be interesting or relevant to people listening to this, considering MBD, how to use it, et cetera?
Yeah, no, I think it's just, a lot of people don't think about it. But I think it's an interesting thing that, people can look into, whether it's something that you're planning on doing for your own designs or not. I think that, like I said, it is kind of an inevitable thing that's happening. And so, just to get educated on a little bit and kind of gain some experience is probably a good idea, especially if you're if you're a contract manufacturer out there, to learn a little bit about model-based definition and have a little bit of an idea of, what it is, what you can do with it, how you should not have to be scared of it and actually be able to make use of it and derive some value from it. That actually could be an edge for you and your company with your competitor or against your competitor, because, your customer might be, very happy that you're able to deal with some of this model-based definition data. So, so I was just say, check it out.
Great. And are there any resources in particular that you recommend to learn more about it? Could be your website as well, but anything out there in particular that you think is really helpful?
Well, yeah, we do. We have a lot of good stuff on our website. We have a pretty active blog there that has a lot of interesting resources about model-based definition. I know that there are a lot of YouTube videos out there in terms of training on how to use some of the CAD tools and how to author model-based definition. And I think the best thing you can do is just get your hands dirty, get out there and start putting some MBD on some parts and see how some of the tools that you have will support model-based definition.
Love it. Love it. All right, Daniel. Well, thank you so much for being on the show today. How can people get in touch with you?
Yeah, just come and check out our website. It's capvidia.com, capvidia.com. Like I said, we have a cool blog section, and just, get in contact with us there, and we'd be happy to talk to you and learn more about what you're doing and see how we could help you out.
Terrific. Awesome. All right. Well, Daniel, thank you so much again. I sure appreciate you being on the show and sharing all this wisdom with us.
Thanks for having me. It's been fun.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.